Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends, today we are starting another sum of Macaulay's double integration method. In this sum, we are taking overall UDL with couple. Let's see in details. This is a question given to us, friends. Using Macaulay's method, calculate the slope of the beam at C as shown in figure. We have to find the slope at C. In the figure, take EI will be 40 into 10 raised to 3 kilonewton per kilonewton meter square. Okay. In that question, what is our first step? First, we have to draw the diagram. In solution, write it over here. Solution. Okay. Now draw the diagram one time again. Okay. Now what Macaulay says first. See, this is a hinge support, this is a roller support. We have to oppose this VA and VB. Now we find out the VA and VB using support reaction calculation. This is our first step. First step our will be calculation of support reaction. In that, what we are seeing first we are taking moment at A equal to 0 clockwise positive. Okay, we are taking moment at A equal to 0 clockwise positive. So what will come? See, this couple is going in clockwise direction, so positive 160 as it is. 160 as it is. Now what is intensity is this? UDL is there, so UDL will coming. See, this is a point fixed over here and applied a load from upward, so it will go like this, so in clockwise direction. So plus 15 into 8 into 8 by 2, this is our UDL. Okay, after that minus VB into this distance, minus VB into 8 is equal to 0. While solving this, you get the value of VB will be 80 kilonewton. Okay, now after that summation Fy equal to 0 upward positive. Okay, now in upward positive, what are the loads coming over here? See, this is, we got the value of VB or 80 kilonewton. Now what are the loads over here? See, this VA is going up, so positive VA. Now see, this UDL is coming downward, so minus 15 into 8. Okay, 15 into 8 means 20, sorry 120. Okay, now after that this will go upward, so plus 80 is equal to 0. While solving this, you get the value of VA will be 40 kilonewton. Okay, now see, we don't take in Y, don't take couple, because it is a moment, it will always come in moment only. Okay, now we have done with the first part, calculate support reaction. After that, what Macaulay says for us, now we have to cut the section. Now what Macaulay says for cut the section, while cutting the section, please remember these things. Cut the section extreme corner, or if UDL is there, cut the section in UDL as Macaulay says. Okay, but here in this question we have overall UDL, so we can cut either left or right. Both the cases are possible over here, so we are cutting our section over here like this. This is our section XX at a distance x from A. Now this is your x distance. Now see, this is the origin, this is your origin. Now what I am doing over here, see, we have to write this box that I am explaining in the previous sum. Now see, this is the origin, that's why this value will come x is equal to 0. Okay, now after that here this box x is equal to 3. Okay, now after that this one x is equal to 8. Okay, now after that what is our next step? Now we have to take the bending moment over here using Macaulay's method. Now our next step will be second step will be using Macaulay's method. Using Macaulay's method, I'm just written over here. Let taking A as origin and now in exam you don't have to write this let taking A as origin. Directly you can take a section let taking A as origin and using Macaulay's method the bending moment at any section at a distance x from A. Thus don't you have to write in exam, directly you can take the origin A and take a section xx and distance x from A. After that draw these boxes, x is equal to 0, then 3 and then 8. After that what we are doing over here, bending moment at x is equal to ei d square y upon dx square equal to, now we have to write the equation. We have to take the bending moment over here in xx. Now what are the value comes over here? See, this is going 40 into x positive 40 into x, as you know the sign convention of bending moment. After that, see, this is going in this direction, so this is also come positive, so 160 into x minus 3 plus 160 into x minus 3 raised to 0. That's Macaulay says for us at the time of couple we have to take the distance also and raise to 0. Okay, please listen this carefully. After that what is done over, what is remaining over here? So remaining is only this from a to x we have written the, sorry, from a to this distance x we have a UDL also. So how you take the UDL? 15 into x by 2. 15 into plus, sorry, see, this UDL is going in downward direction because we are taking bending moment over here and load is coming from upward, so this will go in this direction, that's in hogging direction. That's why we have to take minus 15 into x by 2. So minus 15 into x by 2, or you can rearrange it once time, 40x plus 160 x minus 3 raised to 0 minus 7.5 7.5, or you can write 15x square by 2. This is nothing but equation number 1. After that what we are doing, we have to integrating the above equation. Now we are integrating the above equation. While integrating, what will get, value we get ei dy by dx is equal to, see, 40x means 40x square by 2 plus 160 into x minus 3 raised to 1 minus 15x raised to 3 upon 6 plus c1. This is nothing but equation number 2. After that integrating once again. After that integrating once again. So how will you get, what's the value you get when you are integrating again? you get the value over here ei y equal to, see, now we are integrating this equation, 40x raised to 3 upon 6, 40x raised to 3 upon 6, this plus 160 into x minus 3 raised to 2 upon 2. See, this is 1. So when we are derivating, integrating again, then it will come 2. Okay. After that, this UDL minus 15x raised to 4 upon 24 plus C1x plus C2, equation number 3. You get all the equations 1, 2 and 3. After that, what is our next step? Our next step is to find, our third step will be, step 3 will be to find C1 and C2. Now how will you find C1 and C2? By applying the boundary condition. Now you have to apply the boundary condition over here. Boundary condition, we know that, so write it over here. We know that x is equal to 0 and y is equal to 0. X is equal to 0 and see, this is the first boundary condition. Okay, in first boundary condition, see the diagram, first boundary condition is this. Here x will also 0, means x is also 0 and deflection y is also 0, because it corners, no deflection is always 0. So that's why x is 0 and y is also 0 in first boundary condition. Put in equation 3. Put in equation 3. We get the value 0 is equal to 0 plus 0 minus 0 plus 0 plus C2. Now you get the value of C2 will be 0. Okay. After that, next boundary condition will be, the next boundary condition is, see, this next boundary condition is this one, this end. Always see the diagram, the supports are the boundary condition. In overhanging part also I had seen in previous question, overhanging part is not a support, it's not a support, so take a boundary condition only a support reactions. Okay, now this is the second boundary, so x is equal to 8 and deflection is again here also 0, so x is equal to 8 and y is equal to 0. X is equal to 8 and y is equal to 0. Okay, put in equation 3. Okay, put in equation 3. So what will come over here? See, when you are putting in 3, as you all know, in note, minus sign and 0, it will cancel the whole term in Macaulay's double integration method. So how will it come over here? See, 0 is equal to 80 into 8 raised to 3 upon 6 plus 160 into 8 minus 3 raised to 2 upon 2 minus 15 into 8 raised to 4 upon 24 plus C1 into 8 plus 0. Okay, now 0 is equal to 8 C1 plus 6.67. Now you get the value of C1 will be minus 783.33. While solving this, you get the value 783.33. Okay, now substituting all this value, now put the value of C1 and C2 in equation number 2 and 3. Now put the value of C1 and C2 in equation number 2 and 3. So put in equation number 2. What is equation number 2 for you? This is your equation number 2. See, this is equation number 2. So put it over here. This is equation number 2. So ei dy by dx. So as it is, EI dy by dx is equal to, see, 40x square by 2 as it is, plus 160 x minus 3 raised to 1 as it is, minus 15 x raised to 3 upon 6 as it is, plus c1. So our minus 783.33. okay, 783.33. okay, now 33. So this is come A. This A is nothing but journal slope equation. Okay, now see, this we are done with the journal slope equation. Our next step will be journal deflection equation, which is nothing but equation number 3. Put the value of C1 C2 in equation number 3. Now see, this is your third equation. This is your third equation over here. Now put the value over here. See, EIY is equal to 40x raised to 3 upon 6 plus 160 into x minus 3 up raised to 2 upon 2 minus 15x raised to 4 upon 24. After that, minus 783.33 into x plus 0. okay, this is nothing but your B equation. Your B is nothing but journal deflection equation. Why is named as journal deflection equation? Because it is y over here. In this second one, in this journal deflection equation, journal slope equation, here is dy by dx. dy by dx nothing but theta. okay, that's why it's a slope equation and it's a deflection equation. Now we have done with this two. After that, in exam you can find anything, slope or deflection at any point as with reference to this x distance. okay, now see what you have to find in the exam, in the question over here. Fourth step will be to find yc over here. This is asking in question over here, to find yc. So to find yc, see the diagram first. To find the yc, or to find the yc, put the value of in C. In C, what is the value of x? X will be 3. So we have to find deflection. Deflection means y equation. So put the value of x in equation number, journal deflection equation. Put x is equal to 3 in equation B, which is nothing but journal deflection equation. So what you will get, EI YC is equal to 80 into 3 raised to 3 upon 6 plus 160 into 3 minus 3 raised to 2 upon 2 minus 15 into 3 raised to 4 upon 24 minus 783.33 into 3. Now see, now rearrange it over here. 80 into 3 raised to 3 upon 6 minus C. This value will get 3 minus 3 will get 0. So what Macaulay says for us, the whole term will be get 0 over here. So after that, minus 15 into 3 raised to 4 upon 24 minus 783.33 into 3. Now you get the value of YC will be minus 2040.61 upon EI, but we know the value of EI over here. So minus 2040.61 upon EI value will be 40 into 10 raised to 3. okay, now answer, we get the answer over here, 0 minus 0.051 in radian. okay, in radian, sorry, not radian, in mm. This is a deflection. Radian come in slope, it's a deflection, that's why it not come radian, come in mm, which is minus indicates in downward directions. okay, so this your final answer will be YC is equal to minus 0.051 mm. okay, this is your final answer. Now we have done with, see the question over here. See the question, we have to find the slope of the beam at C. Slope of the beam at C. Now we have done this part. Slope at C we have to find out minus 0.051 mm. Minus sign means downward deflection. Okay. I hope you understand my videos. I hope you understand my videos. Share with your friends and don't forget to subscribe the Ekeeda channel. Thank you.